Yeah, when the requirements are well defined, the early phase of development continues. So this is more a topic focused on the discrete industry, model-based systems engineering. We support here the development of complex products, which are actually systems, not only consisting of physical parts, mechanics, electric, electronic, but more and more software as part of it. So engineers from different disciplines are then being integrated in the detailed development, have to collaborate. And a basis for that collaboration and joint work on this development, for that is often used to define the architecture and the behavior on a more abstract level. So you start in this early development to define, to use SysML models. So we use this notation SysML to define what are the functions, for example, this product shall fulfill to implement certain requirements. You have a set of functions. From there, you get more and more concrete. From the functions, you define the logical decomposition of the product. What are the logical objects that you intend to develop to fulfill certain functions? And also the behavior of the product. You use different kinds of diagrams, like starting with use case diagrams, sequence diagrams, and so on. So we are supporting all those types of SysML diagrams to allow this model-based systems engineering. It helps to define the interfaces also when it comes down to the detailed development of the specialists in the different disciplines. What are the interfaces between each other when you develop a certain software also? You need to know what to consider, what are the interfaces in terms of mechanical objects, for example, but also your neighbor products when it's about physical products, one mechanical object being in neighborhood of the next one. All those interfaces are defined here. You have a graphical language that you're using. There's only one example shown, the block definition diagram, quite a simple one in this screen here that can be used for that. Again, here we can use, like starting from requirements, we have all the traceability in the system and use a graphical notation, a graph that helps you to navigate between the different objects. We have the integration to the collaboration here as well. And we recently, last year, developed certain functionalities to describe features and early variants of the product, starting with the definition in the requirements, defining variants in here that will then be realized further down in the system in the detailed development phase. Let's have a look at the next slide. Again, this is a high-level process view. So the development in this early development phase starts with the defined and released requirements. We have these in total 9 types of SysML diagrams that can be used for this behavior and architecture definition of the product. But what is important, it's not only linked to the, let's say, left side, starting even with the feedback, the needs, requirements, and then this system modeling. But it's also important to connect and keep those links in the system to the right side when the detailed objects are maintained in S4, or it can also be ECC with some on-top customizations that are needed. We can also connect to BOM document and material, for example, objects in ECC systems. So we have this full traceability about why do I have certain developments done and how are they implemented in the system. We support an XMI file exchange of SysML diagrams if you want to exchange with a partner using a different SysML modeling tool. And we support, for example, integrations to ANSYS functional safety analysis. We can hand over requirement models and SysML diagrams to do a functional safety analysis in ANSYS tools, get the information on critical parts, what's the functional safety, what needs to be considered there, and also in the software development environment in ANSYS, and also further detail out requirements, hand them back to the requirement management in EPD. So different scenarios are supported here. And finally, we can connect to a product structure or even generate a product structure from a SysML block definition diagram. Yeah, one recent development also that we did is a matrix that helps you to get an overview. For example, starting from a requirement model that you see on the left side, what are the linked objects we maintain already since the beginning of EPD, all those links, and you can show them in the graph, in the impact analysis. But with this matrix, we make it easy to get a full view of links between requirements here in this case, and also the same requirements in that case on the top line here. So you see which different types of links are defined between different requirements in the same model. You can also switch to a different requirement model, so defining requirements from one model to requirements in a different model, or also, for example, to a SysML diagram representing, for example, the functional structure. You can see and also maintain in this matrix here all those links easily by selecting the different fields here in this matrix, just selecting which kind of link you want to have between the two objects, and then it's maintained in the system. We're currently enhancing this functionality to be even more flexible, to start also from SysML diagrams on the left side and have functions on the top or other SysML diagrams. So to have the full flexibility between all kinds of objects to use this possibility of a matrix here.